Hello, young chemistry lovers, YCLs. Let us start discussing the third example of redox and non-redox reaction in the context of studying the secret of chemical reactions belonging to either redox type or non-redox type. And during our discussion, we shall also discuss officially about oxidation number. What is oxidation number? And the reaction that we study today is the reaction of red hot iron with steam, superheated steam, and the non-redox reaction that we shall study is quicklime reacting with water. Formally take up what is oxidation number, or we call it ON, or also called oxidation state, or OS. It is a hypothetical charge that can be acquired by an atom if all the covalent bonds are broken in a manner that the bond pairs of electrons are transferred to the more electronegative atom. It is a hypothetical charge in a covalent molecular ion. If the two atoms are identical with same electronegativity, then each gets back its own electron and no one acquires any charge. The oxidation number in that case is 0. And remember, oxidation number is determined for a single atom, not for a polyatomic ion or for a molecule as a whole. For a single atom in a covalent molecule or in a covalent ion. Now, for example, we take water as the simplest case where there are two covalent bonds. Each bond is made up of two electrons, one contributed by each of the two participating atoms. Here also the same. So, you just imagine that these bonds break hypothetically so that the two electrons are transferred to the more electronegative oxygen atom. So also in this case. So oxygen in that case will gain two additional electrons and therefore will acquire an oxidation number of -2. It's a fake charge. It's not a real charge. It's a fake charge. Therefore, the convention is the sign first, then the numeric value -2, +5, +7, not 7 plus, 5 minus, 2 minus. So first the sign, then the numeric value. So oxidation number of oxygen is -2 here, and each hydrogen has lost one electron, will acquire +1 charge. So the oxidation number of hydrogen is +1 in each case. Take the case of ammonia. Nitrogen is also more electronegative than hydrogen. So these pairs, 3 pairs, will be transferred to nitrogen. So nitrogen will gain 3 additional electrons, and for the reason which it will have oxidation number of -3. And as usual, each hydrogen will have an oxidation number of +1. Take the case of sulfuric acid. Of course, as a school beginner, 9th and 10th, you need not have to know the Lewis structure of all the covalent molecules and ions. Just to make you understand the concept, I have drawn the Lewis structure of sulfuric acid. And if you are asked to find out what is the oxidation number of sulfur, what do you do? Since oxygen is more electronegative than sulfur, so all the electron pairs, bond pairs, will be transferred towards oxygen, away from sulfur. So sulfur will lose 2 electrons in the upper side, it's a double bond, 2 electrons in the lower side, it's a double bond, 1 electron each in the left and right side. So altogether it will lose 6 electrons. So the hypothetical charge or the oxidation number is +6. That's it. And if the two atoms are same, like Cl2, O2, Br2, O3, S8, P4, In all these cases, the bond will not break in a heterolytic manner. So this kind of breaking is called homolytic cleavage or breakage, in which each gets back its own electron. So no additional electron, no loss of electron. So each has an oxidation number of 0. Now let us, for the school level, we will follow some simple rules to determine oxidation number in case of simple molecules and ions. Needless to repeat that oxidation number is determined for a single atom. I repeat, single atom. These rules are: number one, for any substance in the elementary state or uncombined state, the oxidation number of the atom is 0. For example, sodium, aluminum, iron, these are the metals. No loss, no gain. And this is chlorine, O2, P4, S8 I was talking about before a bit. So all in these cases the oxidation number is 0. And the second rule is oxygen has always an oxidation number of -2, except in peroxides in which it is -1, I'm sorry. And in superoxide it is -0.5, and in oxygen difluoride it is +2. So we'll not discuss anything about this now. -2 is the usual case. Similarly, the third one is hydrogen is always +1, except in metal hydrides in which it is -1, like sodium hydride, calcium hydride, aluminum hydride. In this case, it will be having -1. And for all monoatomic ions, like sodium ion, aluminum ion, sulfide ion, chloride ion, in all these cases, whatever valency is given in the molecule, the oxidation number will be same. So the oxidation number is same as its charge or valency. If it is iron, you have to know whether it is ferrous iron 2 or ferric iron 3. So these are monoatomic ions, oxidation number and valency, they are one and the same, but valency has no sign, but oxidation number has a sign. Fluorine in a compound always has an oxidation number of -1 because it is the most electronegative element in a compound. And the last but one rule says in a neutral molecule, covalent molecule, the sum of oxidation number of all atoms is 0. For example, sulfuric acid. Let us find out what is the oxidation number of sulfur. We have done it through structure, but we shall now do following simple rules. If hydrogen is +1, according to rule number 3, then for 2 hydrogen, it will be 2 times +1. Plus, let's say sulfur has an oxidation number of X. Right. So plus X, there is 1 sulfur and there are 4 oxygen. So each oxygen has -2, so 4 times -2. So the sum of all these will be equal to 0 as per this rule, because it's a neutral molecule. So X comes to be +6. You have to give sign. You can't neglect sign. You can't write 6. Always you have to put a sign. Although +6 means 6. 6 means +6. But you have to give plus sign. So the oxidation number of sulfur in this sulfuric acid molecule is +6. This is not a real charge. It's a peg charge. What is called the oxidation number. The last rule is in a polyatomic ion like nitrate ion, phosphate ion, sulfate ion, bicarbonate ion. In a polyatomic ion, the sum of oxidation number of all the atoms is equal to the charge of the ion. For example, phosphate ion. Let's find out the oxidation number of phosphorus. So let's say it is X plus 4 times -2. Is equal to -3 because the charge of the real ion, phosphate ion, is 3-, so it will be -3. It's not a neutral molecule like sulfuric acid. So -3, that comes X is equal to +5. X plus 4 times -2 is equal to -3, and that gives X is equal to +5. So phosphorus has an oxidation state of +5 in phosphate ion. Remember, this oxidation number is not the real charge. So put it inside a circle to distinguish between a real charge and a fake charge. This is a real charge, but this is a fake charge. Similarly, I have given some examples. Next, we shall discuss how to find the oxidation number of aluminium and sulfur in aluminium sulfate. Since aluminium is a monoatomic ion, its valency is 3, therefore its oxidation state is +3. There is no need to put X method or algebra method to find. It is a monoatomic ion having no variable valency, so it is +3. But sulfur, either you can find for sulfate ion which is present in aluminium sulfate, or if you are a little novice, then we can apply for the whole molecule. For 2 aluminium, 2 times +3, plus there are 3 sulfur atoms, so 3 into X, and there are 12 oxygen atoms, so 12 times -2, and that is 0. It's a neutral molecule. X is found to be +6. Same thing, whatever we got for sulfuric acid, the same sulfate ion is present here, so it is bound to be +6, right? Similarly, sodium nitrate, you find for sodium, you also find for nitrogen. For sodium, this monoatomic ion rule is applicable. Sodium is a monoatomic positive ion, so its valency is 1, so it is +1. And say nitrogen is X. So it is for nitrogen +1 for sodium and +X for nitrogen, and 3 times -2 for 3 oxygen atoms is equal to 0. It's a neutral molecule, so X comes to be +5. So nitrogen has an oxidation number of +5 here in sodium nitrate. So also in P2O5, if X is the oxidation number of phosphorus, there are 2 phosphorus atoms, 2X, plus 5 times -2, that is equal to 0, so X comes to be +5. Similar, ammonia, hydrogen is always +1, although we have a habit of writing NH3, not S3N, just for convention, but hydrogen is +1 here. It's not a metal. Nitrogen is a non-metal, so hydrogen is a +1, and 3 times +1 plus X is equal to 0, so X is equal to -3. Same thing will happen in ammonium chloride. Nitrogen is supposing X, this is 4 times +1, and chlorine is -1, because chloride ion is a monoatomic ion. Chloride ion is a monoatomic ion, so -1, so that is equal to 0, so X comes to be same -3. Say it's a permanganate ion. In permanganate ion, say Mn is X, 4 times -2, and the sum is equal to the actual charge of the ion is -1, so X comes to be +7. So manganese is +7 oxidation state in permanganate ion. In sulfite ion, sulfur will be found to be +4 in a similar manner. So, but in many cases where there are more than one atoms of a particular element, we often get the average oxidation number. For example, in N2O, what we call the laughing gas, we have to have 2X -2 is equal to 0, so X is equal to +1. So this is the average oxidation state of one nitrogen in a molecule having 2 nitrogen atoms. In a higher stage, you will know which nitrogen has which oxidation number once you know the Lewis structure. That is not discussed in your level. In thiosulfate, this is thiosulfate ion, there are 2 sulfur atoms of 2 different oxidation states. But if you apply the X method, you will get the average oxidation state of sulfur is +2. Similarly, this is what we call Fe3O4, ferroso-ferric oxide, or it is called magnetic oxide. So it contains both FeO, ferrous oxide, as well as ferric oxide. And if you add them, you will be finding, Fe3O4. So one FeO is ferrous, iron is in the +2 state, and one Fe2O3, there are two iron atoms having oxidation state +3. It's not iron atoms, iron ferric ions +3. So one is +2, the other two are +3. So add three of them, +2, +3, +3 becomes +8, and there are three iron atoms divided by 3. So the average oxidation state of each iron is +8 by 3. The same thing you will get in the X method. 3x plus 4 times -2 is equal to 0. So X comes to be +8 by 3. But this is not the oxidation number of any of the iron atoms. This is average. Similarly, this is called the red lead. So this red lead is nothing but PbO, 2 PbO dot PbO2. So there are 2 moles of PbO and 1 mole of PbO2. So here Pb is in the +4 state, plumb state, and here each of the lead will be in the +2 state. So if you add them, it will be Pb3O4. And the average you will get +2 +2, that is +4, and 1 +4 together +8 shared by 3. So the average will be 8 by 3. That also you get by X method. So in a higher stage you will know which is which of course I have told you in this case 2 lead are of +2 type and 1 of +4 type. Similarly, in this compound, what we call magnetic oxide, we get 1 iron in +2 and the other 2 iron is in the +3 state. Let me tell you, oxidation number or oxidation state is now synonymous to valency. Nobody calls valency now. Everybody says, what is the oxidation number? What's the oxidation state of this atom, this element in a compound, right? So even in ionic compound, the valency term has been replaced by oxidation state, although oxidation number concept was introduced for covalent compounds. The concept of ON is very important because it has made the analysis, the study and prediction of innumerable inorganic reactions easily you can predict. So although it is a peg charge, but its study is very important to monitor the fate of a reaction. We shall take 2 examples in the next video. Bye.